Good morning. Today we're going to talk about Math 111 and in particular Section 5.8. Now Section 5.8 is entitled Summary of Factoring Techniques. I'll just call it Summary of Factoring. There's 3 or 4 different types of factoring we covered. GCF factoring, trinomial factoring, difference of squares factoring. There's other types of factoring left to cover, but indeed this section kind of jumbles them all together, and you'll have to pick the right tool in the toolbox to accomplish these problems. Let's start with example 1. This is on page 434. Kind of a nasty looking thing. Let's write it down. 12x squared y squared z cubed. Okay, that's one monomial minus 2x y squared z cubed minus 4 y squared z cubed. All right, clearly this trinomial of degree, let's see, this is degree 7 trinomial, has some common factors. All right, and what I'll usually do is look at the coefficients first. The coefficient, let's see, 12 and 2 and 4. What's the greatest common factor of 12 and 2 and 4? Well, of course, that's going to be a 2. Let me do some side work here. I'll list my GCF here. It's going to be 2. How many powers of x do I have common to each term? Well, there are none, right? There are none common to each. Notice this last term doesn't have any powers of x, right? So x can't be included in the GCF. How many powers of y are common? Well, I've got a y squared, and a y squared. So clearly y squared is going to be part of our GCF. And z cubed, z cubed, z cubed. I've got 3 factors of z common to each. So the GCF is going to be 2y squared z cubed. So I'll be able to take that out according to my distributive law, really working my distributive law in reverse. 2y squared z cubed times what's remaining. Well, I'll have a 6x squared in the first slot minus x is all that's left in the second slot once I factor out the GCF minus 2. All right, many students would stop here, but I think you will be able to factor this trinomial. I can factor again using another factoring technique within the same problem. So let's see if I can break this down further. 2y squared z cubed times, let's see, I believe this is going to factor as a trinomial factoring. I think if we put 3x and 2x in the first slots, I can then play with the possible factors of 2. I'll need my inner and outer sum to add up to a negative x. And I think I can do that with a 2 here and a 1 here. Check it out. I'll have my outer product will be 3x. My inner product will be 4x. And again, I can play with a sign to get that to add up to a negative x. And of course, 2 times 1 is 2. And I'll see what I can do with the sign here. I believe this is negative here and positive 1 here. Let's try it. 3x times 2x is 6x squared. The outer product, 3x minus 4x, indeed adds up to minus x. And minus 2 times positive 1 is minus 2. So it indeed does check. So as we've seen before, there are often times when you need to factor twice within the same problem. So here is our completely factored answer. 2y squared z cubed times 3x minus 2 times 2x plus 1. All right, let's look at example 2. This is example 2 on the facing page, page 435. We get 48 a to the 4th times c cubed minus 3b to the 4th c cubed All right. A to the fourth c cubed minus 3b to the fourth c cubed. All right, always look for a GCF first. If we are asked to factor this, look for a greatest common factor first. It almost always pays off. There isn't always a meaningful one, but if there is, it will certainly make your job easier in the long run. All right, what's the GCF? Let me do a little side work here. The GCF, well, again, I'll look at the coefficients. What's the GCF of 48 and 3? Well, I believe I can factor out a 3, right? 48 is 3 times 16, so I can grab a 3 from both of those coefficients, a factor of 3 from both of those coefficients. Similarly, how many powers of a are common to both terms? Well, there are no powers of a that are common to both. That's what GCF means, C for common, right? Well, how about c, powers of c? Well, of course, c cubed is a common factor to both terms of this difference. So the GCF is going to be 3c cubed, so I'm going to factor that out first, and then see if I can factor further with what we have left. 3c cubed, well, 48 times is 3 times 16, right? So I'll have a 16. If I take out the c cubed, I'm going to have an a to the fourth power left here, minus, in the second term, if I take out 3c cubed, factor out 3c cubed, I'll have a b to the fourth power left. All right, so I've successfully factored out the GCF, but don't stop here, all right? If you look at this second polynomial here, it's got it's one of our patterns, right? It's a difference of squares pattern. 16 is a square. Any even exponent can be written as a square. So let me factor again that second polynomial. Equals, I'll have 3c cubed. Difference of squares always factors in the form a plus b, a minus b, where a is really the square root of this expression here. So it's going to be 4a squared plus b squared times 4a squared minus b squared, working out my difference of squares pattern. So let me write that out. This is a difference of squares. And you'll recall a squared minus b squared always factors as a plus b times a minus b. All right, so there is our final completely factored answer. All right, you haven't factored until you factored completely. All right, let's see. I'm going to do some of the problems in the homework list. This is going to be number 25. And the exercise said on page 437. And the instruction is to factor completely the following expression: 4x squared y squared plus 4xy squared plus y squared. All right, so we've got a polynomial, a trinomial really, a trinomial of degree 4, right? This first term is the term with the highest degree, so it's a degree 4 trinomial. All right, always, always, always look for GCF first. All right, and what is the GCF? Well, it looks like, well, I can't factor out a 4 from everything. This third term does not have a 4. There are no powers of x in this third term, so it looks like the only thing I'm going to be able to factor out is powers of y, in fact, 2 powers of y. So the GCF is y squared, so I can say this is equal to y squared then, times, well, what's left when you factor out the common factor of y squared? In the first slot, there's going to be 4x squared, of course. In the second slot, it's going to be plus 4x. And in the last slot, there's going to be a 1. Remember, the invisible coefficient 1 becomes visible when you take out everything here from that third slot, okay? All right, again, don't stop here. I'm thinking this does factor. Okay, I think, let's see. Again, the more of these you do, the more practice you get, the farther back you see things coming. I think I can factor this as with 2x and 2x in the first slots, 2x and x. If this is positive, both of these signs are the same. If this sign is also positive, they must be the same positive. All right, and 1, well, 1's got only one option, 1 times 1. But I believe this does work. First product is 4x squared, that's fine. The outer and inner product add up to a 2x plus 2x is 4x, that's fine. And the last product, 1 times 1, is positive 1. Wonderful. I think our book would list this answer. Notice this, both of these factors here in this expression, the parentheses expressions, are identical, so I can really write this as y squared times 2x plus 1 squared. On test day, I'd say either of these answers, either of these bottom two lines are acceptable, but I think our textbook to save ink would probably write it in shorthand like this. All right, let's see what else we can cook up here. I'm thinking about number 34 in the homework list. And the exercise list, 34, we've got 625 x to the 4th power minus 256 y to the 4th power. All right, well, again, a lot of students will panic on a problem like this on test day, but if you keep cool and remember your different types of factoring, we should be able to complete it without too much trouble. It's one step at a time. What's the first step? GCF. Always look for a GCF first. 625 is a power of 5, right? It's 5 to the 4th power. 256 is a power of 2. And 5 and 2 have no common factors, so if I look at these coefficients, there's no GCF I can take out of both. All right, x to the 4th power, y to the 4th power, well, there are no common powers here either, so there's no meaningful GCF. Well, there's always, to write none is technically incorrect. There's always a GCF of at least 1 and or negative 1, but those aren't very meaningful and won't help us here. All right, there's no practical GCF that I can take out here, so what I'm going to do is try to factor this as a difference of squares. 625 I can write as a square, since this is 5 to the 4th power. 256 I believe I can write as the square of, let's see, 16, isn't it? Yes, 16 squared. 16 times 16, 6 times 6 is 36, carry the 3, 6 times 6, 96 plus 1 is 16. So I get 6, 50, yes, 256. So 16 squared is indeed 256. So I can write this as a difference of squares. Well, again, I'll do it a little more formally here. I can write it as 25 x squared squared, right? 625 is 25 times 25 minus 16y squared squared. Okay, so I've formally rewritten the original expression as a difference of two squares, something squared minus something squared. All right, so now I can break it down according to my difference of squares formula. It's going to be 25x squared plus 16y squared, the sum of those bases in the second line, times 25x squared minus 16y squared. Okay? All right, now don't stop here. Now this is a sum of squares, and sum of squares is always prime. Right? Sum of squares does not factor. But notice this second factor that's emerged, that has emerged, is again a difference of squares. So I'm going to apply my difference of squares pattern again within the same problem, right? All right, this prime factor I'll carry down to my final answer. And now applying the difference of squares pattern to this binomial, I'll get 5x plus 4y times 5x minus 4y. And I believe that's as far as we can go. So a kind of nasty looking expression to start with was kind of tamed by the factoring process. Again, factored twice really within the same problem. I'll do two or three more today. Let's see, this is number 37 in the homework list on page 437, exercise or study set 5.8. Let's see, factor completely. 6x squared minus 63 minus 13x. All right, where you have a polynomial of degree 2, or a trinomial of degree 2. I'm thinking we might have a shot at this. Sometimes they're prime, sometimes they're irreducible, but I think here we'll have a chance if we get it in standard form. By that I mean using our commutative law to rearrange terms in decreasing degree. All right, standard form of a polynomial expression is arranged terms in decreasing degree. Always, of course, easier to factor if terms are arranged in decreasing degree, and again, I mean by left to right, okay? All right, let's try something here. Again, it's basically a trial and error process. I think I see something here. I'm going to try 3x and 2x in the first slots. All right, so I know the first product is 6x squared. That's fine. The outer and inner product's got to add up to a minus 13x. And of course, the last product have to multiply to a 63. All right, 9 times 7 is 63, so I'm thinking 9 and 7. Let's see. Let me think for a minute. I'll try 9 here. Oops. 9 here. And 7 here. Let's see how that looks. The outer product here, again, this is the real battle, is the inner and outer product adding up to a minus 13. I'll get a 27x for the outer product and 14x. Oops. Hang on. All right, let me try it again. We've got a 27 for the outer product, and the inner product will be 14, okay? 14x. So 27x outside, 14x inside, and yes, I can play with the signs of those terms to add up to a minus 13, right? A minus 27 plus a positive 14 will add up to a minus 13. All right, so let me erase the marks here. Get my bigger eraser. All right, so here we go. I'll need a minus 27x for the outer product and a plus 14x for the inner product. And minus 27x plus 14x is indeed minus 13x. All right, so final answer, 2x minus 9 times 3x plus 7, or you can, of course, you can rearrange the factors any way you like using your commutative law. This answer is fine, this answer is fine, okay? All right. All right, let me get a fresh screen and we will call it a day with one more, just one more, number 38. 8 to the 4th b squared minus 20 a squared b squared plus 64 b squared. All right, again, we want to factor completely. Again, spot the GCF. Clearly, we're going to have some meaningful GCF here. And let's see. Well, the coefficients, there's only a 1 here, really an invisible 1 coefficient here. So no meaningful GCF from the coefficients. Powers of A. Well, notice this third term doesn't have any powers of A. Remember, C means common. It's got to be common to all. So no powers of A come out. But, of course, I see B squared and B squared and B squared and all three terms. So that means I can factor it out according to my distributive law. What's left inside? A to the 4th minus 20a squared plus 64. A trinomial of degree 4. All right, notice this first term has a power of 4 here, but the second term has a power of 2. I think I can factor this as a trinomial factoring using a squared and a squared in the first slots. Let me try it. All right, then the first product will be a to the 4th power, and the outer and inner products will be indeed multiples of a squared. All right, 64. Well, 8 and 8. Let me think. I'm thinking 64, 16 and 4. 4 times, yes, 16 and 4. 4 times 16 is 64, right? And I can play with the signs of 16 and 4 to add up to a negative 20, if I can assign them both negative signs. So I think I've got it here, minus 4, a squared minus 4 times a squared minus 16. Let me check it. First product is a to the 4th power. Outer product is minus 16a squared. Inner product is minus 4a squared, and then indeed that does add up to a minus 20a squared. And the last product, negative times negative, is positive 64. Looks good. All right, so I factored out the GCF. I factored the remaining trinomial as a trinomial factoring, but notice both of these are difference of squares now. So this is really going to town here. Factoring really 4 different times in this problem. A squared minus 4 breaks down as a plus 2a minus 2. A squared minus 16, of course, breaks down as a plus 4 times a minus 4. All right, so final answer, b squared times a plus 2a minus 2 times a plus 4 times a minus 4. So really 4 different factorings involved in getting this into simplest form. All right, we'll call it a day. This concludes section 5.8, summary of factoring techniques.